Okay, so talking about probability. Okay, and see, the machine learning algorithm that we're going to do in few days from now is foundationally it's based on probability. Okay, because what essentially algorithms will do is trying to figure out what has the maximum chance, what has the higher probability of happening. Okay, so looking at the data
Same,
set,
sir.
yeah,
So last class we have not completed that part where what we are doing.
we did that, right? Okay, one second.
Yes, sir.
Okay, so yes, so saying that probability is the foundation of your machine learning algorithms. Algorithms is actually finding the probability, and then we have something called as functions, activation functions that will convert the probability into final output. Okay, so if I need to know, should I, will customer come or not? Yes or no, right? So your algorithm will say probability of yes is 75 and probability of no is 25, right? 1 minus, okay. So you'll say, okay, since probability of yes is 75, answer will be 70 yes as the answer. Okay. So that's why we need to understand a little bit of probability. Anyway, we are doing our programming. Okay. So we are not deriving any algorithm. So we don't need to get deeper into that, but you need to understand a little bit of statistics so that when you talk to people or when you try to explain, you'll be able to explain in terms of probability. So what is probability? Probability is the chance, correct? Okay. So see here, as this paragraph says, the machine learning, not the deep learning, the machine learning is based on Bayesian probability. Okay. And we'll see what Bayesian is. End of this chapter, we need to know what Bayesian is and how we are, when we say Bayesian probability, what does that mean for us? So what is probability? Probability is a chance, correct? And probability is defined by two values. One is,
Zero. Mm.
denominator, which talks about all the possible outcome, all the possible values. That's your denominator. And numerator will be the one that you are interested in. Okay, out of those, all the options, in which options are you interested in? So if I ask you, what is the probability of getting head when I toss a coin? So when you toss a coin, okay, what all things can you get? Head
Heads and
and tail,
tails.
right? So your head and tail will be at the bottom of the denominator. What are you interested
50%.
in? Head. So it becomes head by head or tail, right? So 1 by 2. So
Oh,
we'll say probability of getting head is 1 by 2.
50%. Mm.
What is the probability of getting head or tail? What is the
Mm.
probability of getting head or tail when I toss a coin?
1/2.
Getting head or tail. That means I'm interested in both. You give me either this or that. I'm okay with both. So your numerator is also 2. The denominator is also 2. So it is 2 by
Mm.
2,
Zero.
1.
One.
2 by 2 is 1.
One.
What is the probability of getting 1 if I toss a coin? Probability of getting 1 if I toss a coin. So denominator will be head or tail. Numerator is 1. Numerator 1 is not
One.
there.
One by
There.
50.
No, so it is 0. What? Because 1 is not the
Uh,
sample space. I'm saying what is the
okay.
probability of getting 1 if I toss a
Mm.
coin, right? And we say
Yeah.
that the coin has only head or tail.
Tail.
So numerator will be 0. Possibility is just head or tail. So what is the
Yeah.
possibility of getting 1? No, 0. So 0 by 2 will be 0. Your probability will vary from 0 to 1. Okay. And it can be anything between 0 and 1, but not
Yes,
less
the
than
range is
0,
zero.
not more than 1. So when you answer, when you solve any problem, and if you're getting, let's say you're getting negative values or more than one values, you know that whatever logic you have used, is not right. Okay. Then
Mm.
if I if I roll a dice, what is the sample space?
6.
If I roll a dice, then what is the sample space? Yes, 6. So sample space will be
6.
either 1 or 2 or 3 or 4 or 5 or 6. So 6. I'm interested in only 4. Number 4, I need number 4. So 4 by, not 4 by 1. You're interested in only one number. So 1 by 6. Or you can say 4 by 1 or 2 or 3 or 4 or 5 or 6. So 1 by 6 is your probability. Okay, you're interested in only one number out of the 6 given numbers or the 6 possible numbers.
We were able to see only in books.
Yeah, I'm talking about book only, no? I'm just explaining you.
I thought that you're writing.
No, no, no. I'm not writing. I'm just trying to explain. Okay, so that is your 1 by 6. Now let's say I toss a coin 2 times. If I toss a coin 2 times, what is the probability of getting one head?
2 times 2.
Yes.
2 times.
So what are your sample space?
2 by 4.
4.
Sample space is
4.
head,
4.
head,
Or
head, or
tail, tail.
tail, or
Tail, tail.
head, tail,
Head, tail.
and
Or
tail
tail
head,
head.
right? So possibilities
Yeah.
are 4. The
4.
numerator, you are interested in one head.
2 head, you said, no?
Okay. Okay. If I say 2 head, then what is the probability? Okay, let me write
2.
this time.
1 by 4.
1 by 4 is right. So I need or sample space is head, tail,
Tail, tail,
head,
tail head.
head,
Head,
tail.
tail.
If I toss a coin 2 times, this is my sample space. I'm interested in 2 head. So 2 head is only one option possible. So 1 by 4.
Yes.
I said I'm interested in 1 head. Now, question is,
3.
are you interested
3.
in exactly 1 head
3 by
or
4.
at least 1 head or at max 1 head?
1 and right.
I'm interested in exactly 1 head. If I'm interested in exactly 1 head, then possible values are T
0.
or head T. I'm not saying that I'm not interested in tail.
Okay.
If I say I don't want tail, then you can say, okay. But what I'm saying is I'm interested in exactly 1 head. Okay, 1 head. So it could be tail head or head tail. So in this case, the
2 by
probability
4.
is 2 by 4.
2 by 4.
2 possibilities by total 4 possibilities. So 2 by
Yeah.
4
Yeah.
or 1 by 2. If I say at most 1 head, when I say at most 1 head, that means it can be 0 head or 1 head. So if you talk about 0 head, it is tail. At most 1 head, so 0 head is tail. When you talk about 1 head, it is head, tail, and tail head.
And tail head.
So you get 3 by 4.
Yeah.
Right? So this is 3 by 4 for it at most, maximum, at most, okay, 1 head. So either 1 or 0. Now you talk about, I'm asking, at least 1 head means it can have 1 head or 2 head. So for 1 head, it is head, tail, head,
And
okay,
head.
and head.
Head.
So this is also 3 by 4. Okay, so that's why you have to understand the question carefully. Question is, okay, tossing the coin 2 times, rolling the dice 2 times. Okay, so when you say rolling the dice 2 times, it is sample space will become double. So it is 2 into 2. If one sample space one time is, if one time sample space is 2, then 2 times it is 2 into 2. 3 times it becomes 2 into 2 into 2, 8. Okay, so so if I say if I'm tossing coin 10 times, 2 into 2 into 2 into 2, 2 power 10. What is 2 power 10?
Same thing.
Okay, so 2 power 10 is 8 into 4, 32. So 32 is your sample space. 2 power
32 नहीं हो
32 होगा. You can calculate and see. So it is, okay, 32 is your sample space. So this is how you calculate sample space. I'm interested in that will become numerator. Okay, so this is how you perform your probability. Okay, so if I say, okay, one last question on probability, then we'll go back to our book. If I roll a dice 2 times, what is the probability that I get a prime number as output?
sorry
3/6.
If I roll a dice 2 times,
2 times.
what is the probability that I get a prime
number.
number as output?
Prime number
Okay, so the total value that you get output is a prime number. So when you talk about rolling a dice 2 times, your denominator becomes 36,
36 yeah
6 into 6. Now numerator, how do you calculate? So your value, minimum value will be 2, maximum will be 12. So between 2 and 12, how many prime numbers do you get? So 2 is prime number, 3 is prime number,
Also,
5 is prime number, 7 is prime number,
11.
okay? 7 is prime number, 8, 9, 10 is not, 11 is a prime number, right? So now you can get 1 plus 1, 3, you can get 2 plus 3 or 3 plus 2. 5, oh, sorry, this is for 5, right? Or you can get 4 plus 1 or 1 plus 4. For 3, you can get 2 plus 1 or 1 plus 2. 5 done 7. 7 can be 5 plus 2, 2 plus 5. 6 plus 1, 1 plus 6.
4 plus 3.
4 plus 3 or 3 plus 4. Right? Now 11. 11, you will only get 6 plus 5 and 5 plus 6. So how many numerator values possible? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Make sense? So this is how we calculate the probability. So you get 15 by 36 and you can evaluate to whatever number it comes to. Okay, let's go back. Okay. So structure of probability that it has to be a random phenomena. Okay. If it is not random phenomena, then it is bias. Okay. Okay. If it is random, then you can get 1 by 2, 1 by 6, or 15 by 36. If it is biased, that on 1 you always get 6, even though you have 1 to 6, but you always get 6 in one die. Right? So it should be random phenomena. So what machine learning algorithm tries to figure out is the relationship between the events, so that it's not random, it's not equality probability, but what is the bias into the system. They try to figure out the bias. Okay, so in a way, machine learning algorithm finds out the bias, and that bias becomes the actual predicted outcome. Even if it is biased, doesn't mean that you get same value every time, right? But probability of those values coming is higher. Okay, so now let's stick to algorithm only, statistics or probability only. So we say that it has to be a random phenomenon. It has to be a random phenomena to be called as a probability. Otherwise, our probability rules will not hold true. Okay. Then later we'll talk about distribution. What is distribution? Distribution means when you perform the experiment more than once. So when I said when you roll dice 2 times, 3 times, 10 times, I'm talking about distribution. When you roll a dice 10 times, I'm talking about a distribution. I'm talking about distribution. That's what distribution is. Performing event, okay, or that experiment more than once. Okay, so product distribution of a continuous random way. So now we spoke about discrete probability and continuous probability. What is discrete and continuous probability? So when I talk about case of discrete numbers means finite set of numbers. Okay, your irrational numbers, your infinite set of numbers are continuous numbered. Weight, for example. Okay, you cannot have limited number of weights.
Yes.
Right? So
Yeah.
since you cannot have, okay, it becomes a no. So what I'm talking about, weight, right? So weight
Yes, great.
becomes your
Yeah.
continuous.
Distribution.
So looking at the value that you are working, you decide whether it is continuous or discrete, because the probability will change. And that's what we will see. If not in this chapter is only about statistics, probability. Next chapter, we will talk about that. Okay. Now, there are different types of distribution depending upon the properties of your file. Depending on the properties of your file, it depends. Okay. We will see, no worries. Now, again, event. What is event? So these are your discrete event. Okay. When you pick a card from a pack of cards, right? A king. So when I say what is the probability that I pick a card and it's a king? So total probability, total sample space is 52. 13 into 4. Each suit, its color is 13 cards. So 13 into 4, 52. 52 is the total sample space. I'm looking for a king. So that you have 4 favorable conditions. 4 by 52. 1 by
Hmm.
13 is your probability of getting a king. Getting a face card. Face card means some, that has image, photo, face. So Jack has
Okay.
photo, Queen has photo,
Okay.
King
And
has
king
photo,
was 12.
right? 4 into 3, 12. Okay. A face card or a red suit. Face red suit are 13 and face cards are 12. So 12 plus 13. How much you get?
25.
Then why does it say 32?
I didn't say 32.
No, no, not you. It's written there. 32. You see that here? Second last bullet point.
I've
See,
seen.
red suit means it can be heart or diamond.
Or that diamonds also. That's what
Correct?
they are
So you
counting.
get 13
So
plus 13,
26 and 12. 26 and 12.
26 and 12,
8, 38.
38. So it's still not 32. Why?
Uh, they are not like including the face card.
Including the face card. So see, when you say 13 plus 13, 26, you are also including the red color face cards. So apart from 26, okay, 13 and 13, 26, it is only the black color face cards, isn't it? 3 plus 3, 6. So 26 plus 6, 32. So if I say that if I pick a card, what is the probability that it is a face card or a red suit? Answer is 32 by 52. Yes?
Yes.
So it is 32 by 52. Okay. This is for throwing dice twice. 6 by 6, 36. Okay. We'll talk about some interesting stuff. Venn diagram also, set we have done. So we'll skip and we will go to conditional probability, because conditional probability is what is important. Okay. Okay. So see here. Probability of a student gets grade A. Okay. So this is grade A and absences. Okay. High absences. So high absences versus grade A. Okay. High absences versus grade A. What does 0, 0 means? They don't have high absences. That means they attend class frequently. They are almost regular, but they have not got grade A. So how many students are there in the class? How many students are there in the class? 277 plus 78. That is 285 plus 355. 355 plus 40. 395. Correct? If you add all these four, you get 395. Do it and tell me, am I correct or not?
You are correct.
Okay, that means you have 395 students, people in the class. Okay, and if you talk about 0 and 0, that means high absence is no, and grade A, okay, grade A, no. So 277 people have good attendance and not grade, they are not grade A. When I say high absence is 1 and grade A is 0, what does that mean? Okay, set theory is based on this. Tell me, what does this mean? High absence is 1 and grade 0. I told you what 0, 0 means. So what is now high absence is 1 and grade A 0. Come on. Why are you so silent, guys?
I don't understand this matrix. 0 are those who are not like regularly joined, right?
That is absences. Absent.
Yeah.
So absent is 1 here. High absent is 1. That means these are the people who are
And
attending classes very less.
the
So
one people.
78 out of 395 people are attending class very irregular. They are missing the class. Okay. And they have not got grade A. They have got grade B, C, D, whatever, but definitely not grade A. 35 people are one who are regular and have got grade A. 35 people have got grade A and they are regular. 5 people are those who are, okay, grade A, but also they are highly absent. They don't attend class regularly
Yes.
and they got grade A.
Yes.
So there are 5 people in the class. Such people are 5 in the class.
Okay.
This will help you to write your story. When you write your story, this is how you will analyze. Data will give you this 2 by 2 matrix. Okay, what does this 2 by 2 matrix says? Now tell me, if you belong to this
Okay.
class, what is the
Understood now.
probability that you will get grade A? If you belong to this class, what is the probability that you will get grade A? Assume that, we are trying to talk about probability, no other factor that you are implementing which will make you bias. So if you belong to this class, what's the probability? Grade A is 35 plus 5, 40. So 40 by 395, that's the probability of getting grade A. If getting grade A is a random phenomena, your probability will be 35 plus 5, 40 by 395. 40 by 395, that's the probability. Now question is, what is the probability that you can be absent but still get grade A? You can be absent and still get grade A. 5 by 395.
5 by total.
Yes.
5 by total, 5 by 395. What is the probability that, okay, you attend class regularly, but you could not get grade A?
277 by 2.
Yes, 395, 277 by 395. That's how you will read and analyze the probability of, okay. Now, this is based on sample data of a class. Can I extrapolate for all the students of this world or of this state or of this city? Can I extrapolate? So this is sample data of a school, of a class, right? Of a
Yeah.
subject. This is math subject. Okay. can I extrapolate that this data is true for all the subjects, for all the schools? So you cannot say,
Cannot,
okay,
yeah.
you need to perform one more extra step. That's what we'll discuss as the last part of our um, uh, statistics. Okay, that is called hypothesis testing.
Distribution.
First, I have to figure out one, is this school or this subject represents the population student,
Yes,
right?
like
I
we
go
have
and
to
talk
find
to,
the class interval.
I go to just one part of a city. I ask about whom they like to vote, and based on that, can I predict for all the states in the all the seats in the state?
No.
I need to make sure if the population in that seat represents the state population or demographics, state demographics. If that is like that portion is like a mini Telangana. So whatever you characteristics you see in Telangana is represented that in that place. Then you can say yes, because that place represents Telangana. Okay, the demographic of Telangana is same as that seat. Then yes, you can extrapolate for entire Telangana. But if not, and mostly it is not, right? It's either rural or it's urban, that itself will divide the people. But if you have a seat where there is same proportion of urban, same proportion of rural, same proportion of male, same proportion of female, same proportion of educated, uneducated, and all those demographics are same, then you can say, yes, this seat represents Telangana, and if I get data right for this seat, I can get it for entire Telangana. But no, if you figure out no, the structure of this seat is not matching to that of Telangana as a whole, then you will say, no, it's not. You cannot extrapolate for entire. So first thing, okay, so still, right? If you say yes or no, if it is no, then definitely no. If that seat doesn't represent entire Telangana, then definitely no, it is no. You will not move to next stage. But if you say yes, it it represents entire Telangana, so that means we can. Next question is, the numbers that you see, is it significant enough to help you make those decisions? Is this significant enough to make your decision? If answer is yes, it is significant enough, only then you will go with this. So one thing, does it represent? No, no means no. The moment you get no, you stop there, you don't proceed. If answer is yes, okay, then good, it is representing. But now the answer that I got, is it significant enough? Can I talk with 95% confidence that, there is that numbers that you see here represents for entire Telangana? Okay, if answer is yes, then you will say, okay, I can now go. So you have two component that is important. One, the population should be same, okay, or similar. Second, should be significant enough. Okay, so we will see that in the third part. So first is status probability, second is distribution, third is the hypothesis testing. We'll see that. Okay, so this is how you calculate probability. Okay, if you add all of these, you get 4. Oh, sorry, you get 1. Okay, if you add all these 4, total probability 1. This probability, what does this 0.01 say? Only
Uh,
0.01. What does it say?
only five, 5% will
So probability of finding
getting top.
someone,
Huh. Like
probability of
they
finding
are getting grade
someone
A,
who have grade A and also
grade
high
A.
absentees is
Yeah.
0.01. Okay, the probability of someone who attends the class regularly but do not get grade A is 0.7. Okay. Okay.
Yes.
Let's go back and see what else. This is called Bayes rule. Bayesian theorem or Bayesian probability is based on Bayes rule. Bayes rule is what we just discussed. Given that, what is the probability of A? Okay, probability A is independent of B. But now I'm talking about probability of A given that. Okay, let's take the same example. Bayesian theorem. What is the probability that you get grade A? So A is, let's say A is getting grade A, B is high absentees. What is the probability of getting grade A? Tell me, what is the probability of getting grade A? Point 0.09 plus 0.01,
This
which is
0.01.
0.1. Probability of getting grade A is 0.1. But question is not getting probability of grade A, which is straightforward question, which is normal probability. Bayesian says, given that it is high absentees, given that you are part of high absentees, given that you are part of high absentees, that means you are part of 0.21. And then what is the probability of getting grade A? 0.01. So 0.01 by 0.21, which is 1 by 21. Because given, I know that he is a high absentees. If I don't know if he's a high absentees, then this is different. I know he is high absentees. So high absentees given, it's open. This is 0.21. This is not included here. I am part of high absentees. So you know that probability that he's part of high absentees. Then no need of getting to this area. So we are playing the total. Here the sample space is 0.1 plus 0.01, 0.21. 0.21 is your sample space. And probability that you get grade A is 0.01 by 0.021, which is 1 by 21. 1 by 21 is definitely more than 0.01. Okay, so that's how we are able to perform what is called as conditional probability or Bayesian probability, given that the formula is this: P of A by B. That means what is probability of A occurring when B is given? You know B is given. Okay, so B is open. Okay, A is P of B of A. That means probability of B occurring when A is given. Probability of B occurring when A is given. P of B of A into P of A by P of B. P of A by B equal to P of B of A into P of A by P of B. Okay, that's what we call as conditional probability or Bayesian statistics. Bayesian probability is when you have given. Okay, question is, what is the probability of getting two heads? Moving to paint. What is the probability of getting two heads when you toss a coin 2 times?
One by 4.
1 by 4?
1 by
Be-
4. Yeah.
Because 2 head and 4 possibilities.
4 possibilities.
Now the question is, what is the probability of getting two heads when you have already got one head in the first attempt? If I already got one head in the first attempt, so I need to only worry about second attempt. First attempt, one head, perfect, you got it, you know it. Second attempt, you can get either head or tail. So your sample space is not HT or TH. It is either H or T, because first one is clear, you know you have got it. So there is no probability there. That is certainty. There is no probability. That is certain. Event has already happened. Okay. So what you do not know is the second event. You do not know if second event has happened or not.
So, what
Okay.
would be the answer if that
Yes. So answer
event is
is,
already happened?
that's what I'm saying. Wait, no, hold on. So you know, so one H already happened, given. So there's no probability required there. It is one. Now I'm saying, second, what do you want? Second, you want one head out of head or tail. So answer is 1/2, not 1/4. 1/4 was when you knew that, when you don't know both the event. See, simple. You need to win 5 matches to win Olympic gold, let's say. You need to win 5 matches to win Olympic gold. Now, when you win first match, that means, are you not closer to winning the Olympic gold? Yes, right? So I want 2 head and I got 1 head. So is it not that your probability will be much higher now? Right? Your probability will increase as you make progress. I need to win 5 matches to win gold, and I won first match. Probability should increase. I win second match. Again, the probability should increase. I win third match. My probability will again increase of winning the gold. As you move closer, okay, so here I needed 2 head. I badly need 2 head, and I got 1 head. Okay, let's say you need 2 water bottle to survive. So, the chances of surviving is very slim. But you got 1 water bottle. When you get 1 water bottle, your chance of surviving has increased now, is it not? Same way, I needed 2 head. Okay, so my probability is 1/4. 2 head by head, tail, head, tail. You know that sample space. But I'm telling you, first is head. I'm opening it, confirming you. You got 1 head. So now second option is, we don't know about the second event. We know about the first event. We don't know about the second event. The second event, you can get either head or tail. So it is, you need head. So it is head by tail or head, 1/2. So your probability is 1/2. I need 2 head. I need 2 head. Given that first one is tail, what is the probability of getting 2 head now? Did you get it? I need 2 head.
2/3, sir.
I need 2 head.
Heads.
And first one is tail. What is the probability of getting 2 head now? I need 2 head. And the sample space is head or tail. Do you any chance of getting 2 head? No. Your 2 head is not part of sample space. So it is 0. You need to win both the matches to win gold. But you lost the first match. Probability of winning gold is 0. Yes?
Yes, got it. Yeah.
Okay. Now I can move it to 3 level. Okay. I'm tossing coin 3 times. I need 2 head. First one is tail. Then what's the probability? Okay. What is the probability of getting 2 head when I toss a coin 3 times? Probability of getting 2 heads if I toss a coin 3 times. So it could be 3. Bottom we know it is 8. 2 power 3, 2 cube. It could be tail, head, head, or head, tail, head, or head, head, tail. No other possibilities. 3 by 8. Correct? 3 by 8. Now, given that first one is tail. So, given that first one is tail, now you need to get 2 head compulsory. And you have 4 possibilities. So, it becomes 1 by 4. From 3 by 8, it went to 2 by 4. You did not get head. So, probability has decreased. Okay. This is called your basis. Do you understand? Conditional probability. This is the basis
Yeah.
for most of the algorithms. Okay. Let's go back to our discussion. Okay. So there's one interesting problem based on that. Okay. It talks about, okay, a game show. Okay. And it appeared in India also by name Khulja Simsim. So as a contestant, you're given 3 doors and you have to choose 1 door. 3 out of 3 doors, 2 doors has goat, okay, and 1 goat has, oh, sorry, 1 gate has car. 2 doors have goat and 1 has car. And they ask you to pick any 1 door. And whatever you pick, you win that. So if what is the probability of me winning a car?
One by three.
Probability
Oh,
of winning a car is 1 by
one
3. You have 3
yeah,
doors
yeah.
and 1 door has car.
And one door
The
is car.
probability of winning
Right.
car is 1 by 3.
Three.
Now
Yes.
game doesn't stop here. Game continues and says you need to pick 1 door, and before they announce the winner, they open the other door which has goat. Now they will ask you, the game host will ask you, do you want to go with the existing selection or you want to change your option? Means if you select goat, okay, this goat is open and they'll ask you, you want to stick to your choice or you want to switch to door 3. Did you get it? So the question is, what will increase your chance of winning? Should you switch the door or should you stick to the same door? So let's go back to the board again. Okay, so you have chosen a door here. Okay, the 3 doors, you have chosen a door. What's the probability of winning car? 1 by 3. 1 by 3, 1 by 3, 1 by 3. Correct? Now, if I open the door and shows you that this is goat, or they always open and show the goat. Now what happens? So see, the probability of winning is 1 by 3. And probability, if you go with this, is 1 by 3. And if you had gone with this, the probability is 2 by 3. You agree? So it is 1 by 3.
Yes.
And this is 2 by 3.
2 by 3.
Now, if I tell you that this is goat, I open and show you this is goat. So the probability of this is 0 now, correct? Because you know that it is goat, you can't win. So now what happens? The entire 2 by 3 probability goes to this door. Entire 2 by 3 probability goes to this door. So the net result is this door has probability of 1 by 3 and this door has got probability of 2 by 3. So it makes sense for you to switch, saying that, oh, I will go with this door. Because the chance of winning the car is twice here than here. All right. So, okay. So in the book, there's a Python program which will run, simulation, and using that you can actually, you know, see what, all these things. So I would say you can run that program and see how we got this value. Okay. So with that, we'll stop today's session. Tomorrow we'll start with probability distribution.